At the edge of our world's familiar landscapes, where the earth itself seems to surrender to an endless expanse of gold and silence, lies the Sahara Desert. A realm so vast it defies comprehension, stretching across more than 3 million square miles of North Africa. To understand the true scale of this desert, imagine the entire United States covered in sand and stone. Now add the whole of Europe on top. That is the Sahara. 9.2 million square kilometers of the most extreme landscape on Earth, representing 8% of our planet's entire land surface. From the Atlantic shores of Morocco to the waters of the Red Sea, the desert spans 3,000 miles. From the Mediterranean coast to the grasslands of the Sahel, it reaches over 1,000 miles south. Eleven countries share its boundaries, yet the Sahara belongs to none of them. It exists as a world unto itself, governed by forces older than human civilization. Most people imagine endless dunes when they think of the Sahara. Rolling hills of golden sand stretching to infinity. But that image captures only a fraction of this desert's character. Sand dunes cover merely 15% of the Sahara's surface. The rest is a mosaic of rocky plateaus, gravel plains, salt flats, and ancient mountains that pierce the sky like monuments to forgotten ages. The Sahara is not one desert, but many. Each region tells a different story, written in stone and sand. In the north-central reaches of Algeria and Libya, the famous sand seas spread their golden waves across the horizon. Here, dunes tower hundreds of meters high, shaped by winds that have blown unchanged for millennia. Some of these giants reach 450 meters into the sky, tall enough to swallow skyscrapers. These are not random piles of sand, but carefully orchestrated formations. Star dunes dominate the Grand Erg Oriental. Their pyramid shapes rising where winds blow from multiple directions. Linear dunes stretch like massive highways across the landscape, some extending for over 200 kilometers in perfectly straight lines. Crescent dunes march across the desert in formations that seem almost military in their precision. Each grain of sand in these mountains has traveled incredible distances, worn smooth by countless collisions, lifted by desert winds, and deposited grain by grain over thousands of years. The formation of a single massive dune is a process that spans human lifetimes, yet the end result appears permanent, eternal. But permanence is an illusion. in the Sahara. This desert breathes with a rhythm measured not in minutes, but in millennia. What seems unchanging to human eyes is actually in constant motion. Shaped by forces both subtle and violent. The climate here operates at the very limits of what Earth can produce. Less than 1 inch of rain falls in most areas each year. Some regions receive no rainfall at all for decades. The air is so dry that moisture evaporates before it can reach the ground, creating phantom storms that tease with the promise of relief, but deliver only disappointment. When the sun rises over the Sahara, temperatures climb relentlessly. Summer days regularly exceed 114 degrees Fahrenheit. The highest temperature ever recorded on Earth's surface, 58 degrees Celsius, was measured here. The ground becomes hot enough to cook food, and the air shimmers with heat that distorts vision and creates mirages of impossible lakes. Yet as the sun sets, the desert reveals another face entirely. Without moisture to trap heat, temperatures plummet with startling speed. The same location that baked under extreme heat just hours earlier can freeze before dawn. Temperature swings of 38 degrees Celsius in a single day are common. This dramatic variation creates a landscape where rocks crack from thermal stress, and nothing soft can survive exposed. The Sahara receives more sunshine than almost anywhere else on Earth. Over 4,000 hours of bright sunlight each year, in some areas, representing 98% of all possible daylight hours. The sky's a dome of relentless blue, broken only occasionally by dust storms that can engulf entire countries. These storms are phenomena unto themselves. Walls of dust and sand that rise thousands of meters into the atmosphere, traveling across continents and oceans. Saharan dust has been found in the Amazon rainforest, carrying nutrients across the Atlantic to feed South American jungles. The desert exports its essence to the far corners of our planet, connecting seemingly unrelated ecosystems in a global dance of wind and weather. Yet even in this realm of extremes, life persists. Not just surviving, but thriving in ways that challenge everything we think we know about the limits of existence. The Sahara hosts over 500 plant species, 70 mammal species, 90 bird species, and 100 reptile species. Each has evolved remarkable adaptations that allow them to flourish where nothing should be able to live. Among the most iconic of these survivors is the fennec fox. The smallest member of the fox family, yet perfectly engineered for desert life. Its enormous ears, comically oversized for its tiny body, serve as natural air conditioning systems. Blood vessels close to the skin surface in these ears release excess heat, keeping the animal cool during scorching days. At night, those same ears become incredibly sensitive listening devices, capable of detecting the movement of insects beneath the sand. Fennec foxes have mastered the art of desert survival. They obtain all the water they need from their food, never requiring a drink. Their thick fur protects them from both heat and cold. Their large padded feet allow them to walk across burning sand without injury. Underground burrows provide shelter from temperature extremes and predators. These remarkable creatures represent the pinnacle of adaptation. Proof that life will find a way, even in the most impossible conditions. The dromedary camel, known as the ship of the desert, embodies another approach to Saharan survival. These magnificent animals can travel 100 miles across trackless desert, carrying heavy loads, guided only by their riders' knowledge of distant landmarks. Their famous humps store not water, as commonly believed, but fat that can be converted to energy and water when food becomes scarce. Camels possess a suite of adaptations that seem almost supernatural. They can drink 30 gallons of water in 10 minutes when they find it. Storing enough to last for days. Their kidneys are incredibly efficient, producing concentrated urine that wastes almost no water. Their blood cells are oval rather than round, allowing circulation to continue even when they become severely dehydrated. Long eyelashes and closable nostrils protect against sandstorms. Large, tough lips allow them to eat thorny plants that would injure other animals. For thousands of years, camels made human civilization possible across the Sahara. Without these remarkable animals, the great trade routes that connected Africa, Europe, and Asia could never have existed. Cities would never have risen from the sand. Knowledge and culture could never have flowed across the desert's vast expanse. The relationship between humans and the Sahara is far more complex than a simple story of survival against hostile nature. This desert has been home to sophisticated civilizations, centers of learning that attracted scholars from across the known world, and trade networks that moved gold, salt, and ideas across continents. But the Sahara's history extends far deeper than human memory. This desert, which seems so permanent and unchanging, has undergone transformations that would reshape our understanding of what deserts truly are. 6,000 years ago, where endless sand dunes now roll beneath the merciless sun, rivers flowed through green savannas. Elephants, giraffes, and crocodiles thrived where today only specially adapted desert creatures can survive. The evidence lies buried beneath the sand, waiting to tell stories of dramatic climate change that occurred long before human influence. Ancient lake beds, fossilized pollen, and archaeological sites paint a picture of the Sahara as a lush green landscape that supported complex ecosystems and human settlements. This was the Green Sahara, a paradise that existed during what scientists call the African humid period. Rock art found throughout the desert depicts scenes that seem impossible in today's landscape. Hunters pursuing elephants and giraffes, cattle herders tending their flocks beside permanent rivers, fishermen casting nets into vast lakes. These are not fantasies but historical records, carved in stone by people who lived in a Sahara we can barely imagine. The transformation from green paradise to harsh desert happened with startling speed in geological terms. Within just a few centuries, the monsoon rains that had sustained this ecosystem shifted south. Rivers dried up, lakes evaporated, and vegetation withered. The animals migrated or died. The people who had called this place home for thousands of years were forced to adapt or abandon their settlements. This dramatic climate shift reveals one of the Sahara's most profound secrets. What appears to be a permanent wasteland is actually part of a vast planetary cycle. Every 21,000 years, changes in Earth's orbital patterns bring the monsoon rains back north. The desert blooms again, life returns. Then the cycle reverses, and the Sahara reclaims its dominion over the land. We are living during one of the Sahara's dry phases, witnessing this landscape at its most extreme. But beneath the sand lie the bones of rivers that will flow again. The seeds of forests that will grow again. The promise of abundance that will return when the great wheel of climate turns once more. This knowledge transforms how we see the desert. Each sand dune covers ancient soils that once nourished vast forests. Every dry riverbed holds the memory of waters that carved these channels when the world was young. The Sahara is not dead, it sleeps, dreaming of rain. Yet even in its current arid state, the desert pulses with hidden life. Deep beneath the surface, vast aquifers hold water that fell as rain when the Sahara was green. These underground seas, some larger than entire countries, sustain the scattered oases that dot the landscape, like emeralds on a golden cloth. The oases represent miracles of geology and human ingenuity. Where underground water reaches the surface, life explodes in impossible abundance. Date palms tower overhead, their fronds creating shade for gardens of vegetables and grains. Cool springs bubble up from depths measured in hundreds of meters. These places have served as lifelines for travelers crossing the desert for thousands of years. Each oasis tells a story of careful cultivation and wise management. The people who tend these green sanctuaries understand that water is more precious than gold. Every drop must be conserved, every plant positioned to make the most of the precious moisture. Traditional irrigation systems channel water through carefully planned networks that have functioned for centuries. The largest of these oases, the Nile Valley, supports one of Earth's great civilizations. The Nile River carries water from distant highlands through the heart of the Sahara, creating a ribbon of green life that has sustained human society for over 5,000 years. From space, this river appears as a single green thread crossing an ocean of brown. A testament to water's power to transform even the harshest landscapes. But the Nile is an exception. Most of the Sahara's water lies hidden far underground, accessible only through deep wells that require enormous effort to dig and maintain. The people who have mastered desert survival understand this hidden geography of water. They can read the subtle signs that indicate underground streams, the particular plants that only grow where their roots can reach moisture, the rock formations that trap and channel groundwater. This knowledge has been passed down through generations of desert dwellers who developed into some of history's most remarkable cultures. The Tuareg people, known as the Blue People for their distinctive indigo clothing, have navigated the Sahara for over 1,000 years. These nomadic Berber communities developed sophisticated understanding of desert navigation, seasonal migration patterns, and the complex social structures needed to survive in such a challenging environment. The Tuareg traditionally controlled the trans-Saharan trade routes, serving as guides and protectors. For the massive caravans that carried goods between North and West Africa. Their deep knowledge of water sources, safe passages, and seasonal weather patterns made them indispensable to merchants seeking to cross this vast wilderness. A single Tuareg guide could mean the difference between a successful journey and death in the trackless waste. These caravans were marvels of organisation and endurance. Some consisted of over 10,000 camels, carrying goods worth modern fortunes across distances that tested the limits of human determination. Gold from West African mines travelled north to Mediterranean markets. Salt, more valuable than gold in some regions, moved south from Saharan deposits to communities that desperately needed this essential mineral. The most precious cargo was often knowledge itself. Scholars, books, and ideas flowed along these routes, connecting civilizations separated by thousands of miles of desert. The great trading cities that rose at key points along these routes became centers of learning that attracted intellectuals from across the known world. Timbuktu emerged as the crown jewel of this intellectual flowering. Located at the edge of the Niger River, where boats from the south met caravans from the north, this city became synonymous with learning and wealth. The University of Sankore attracted scholars who came to study astronomy, mathematics, literature, and theology in libraries that housed hundreds of thousands of manuscripts. These manuscripts, many of which survive today, reveal the sophisticated intellectual culture that flourished in what outsiders considered a barren wasteland. Mathematical treatises, astronomical observations, philosophical debates, and literary works demonstrate that the Sahara was never truly isolated from global currents of knowledge and culture. The wealth that supported this intellectual achievement came from the desert itself. Beneath the sand lay deposits of gold, salt, copper, and other minerals that made those who controlled them incredibly rich. The gold mines of West Africa produced the metal that became the foundation of Mediterranean and Middle Eastern currencies. Salt deposits in the Central Sahara were so valuable that they were literally worth their weight in gold in regions where this mineral was scarce. Modern technology has revealed that the Sahara's mineral wealth extends far beyond what ancient peoples could imagine. Vast deposits of oil and natural gas lie beneath the sand, along with substantial reserves of iron ore, uranium, and phosphates. These resources have transformed parts of the desert into centres of modern industry, though often at the cost of traditional ways of life. The discovery of oil in particular has brought dramatic changes to Saharan communities. Where nomadic herders once moved their animals across seasonal grazing grounds, pumping stations and pipelines now mark the landscape. The wealth generated by these resources has built modern cities in places where only oases existed before. But it has also disrupted traditional social structures that had adapted to desert life over countless generations. Yet the Sahara continues to shape those who encounter it, just as it has for millennia. The desert strips away pretense and reveals fundamental truths about survival, adaptation, and the relationship between humans and nature. Modern travelers who cross its expanse often describe profound spiritual experiences. Moments of clarity that come from confronting the raw power of this landscape. Scientists studying the Sahara have made discoveries that challenge our understanding of desert ecosystems and global climate patterns. Research has revealed that Saharan dust storms play a crucial role in fertilizing distant rainforests. that underground rivers connect oases separated by hundreds of miles. And that life exists in forms and places that seem impossible. Microorganisms thrive in salt deposits so harsh they were once thought sterile. Plants survive in crevices where temperatures would kill most living things. Animals navigate by stars and magnetic fields across distances that would challenge modern GPS systems. Each discovery adds new chapters to the story of life's incredible resilience and adaptability. The Sahara also serves as a laboratory for understanding climate change on a planetary scale. The desert's dramatic transformation from green paradise to arid wasteland provides insights into how quickly and completely ecosystems can shift when climate patterns change. Scientists studying ancient climate records from Saharan lake beds and cave formations are learning to read the signatures of past climate changes. Knowledge that helps predict future shifts. Recent research suggests that the Sahara may be entering another period of change. Climate models indicate that rising global temperatures could bring increased rainfall to parts of the desert within this century. Some areas could see precipitation increase by 75%, potentially triggering ecological transformations that would reshape this landscape once again. The possibility of a greening Sahara raises profound questions about the future of this region and its peoples. Would increased rainfall restore the ancient lake systems and grasslands? How would traditional desert cultures adapt to such changes? What would happen to the unique ecosystems that have evolved to thrive in extreme aridity? These questions remind us that the Sahara, for all its apparent permanence, remains a dynamic system. Responding to forces that operate on timescales, both vast and immediate, the desert that seems so stable and unchanging is actually in constant motion, shaped by winds that redistribute its sand grain by grain, by underground waters that flow along paths carved millions of years ago, by climate cycles that operate across millennia. Human presence in this landscape represents just the latest chapter in a story that began long before our species existed. Yet our impact on the Sahara and its impact on us continues to evolve in ways that will shape both the desert and human civilization for generations to come. Civilization for generations to come. The relationship between the Sahara and the global climate system extends far beyond its borders. Reaching into the most unexpected corners of our planet. Every year, massive dust storms lift millions of tons of mineral-rich sand high into the atmosphere, creating rivers of particles that flow across oceans. These aerial highways carry nutrients from ancient Saharan lake beds to the Amazon rainforest, where they settle among the trees and enrich soils thousands of miles from their origin. The phosphorus in this dust, eroded from rocks that once lay beneath prehistoric lakes, provides essential fertilizer for South American jungles. Without this annual delivery from the Sahara, the Amazon ecosystem would struggle to maintain its incredible biodiversity. The desert that appears so lifeless actually nourishes one of Earth's most vibrant ecosystems, demonstrating the hidden connections that link all life on our planet. These dust storms also influence weather patterns across multiple continents. When Saharan particles reach the Atlantic, they can suppress hurricane formation by creating dry, stable air masses. The same dust that fertilizes rainforests also protects Caribbean islands from devastating storms, showing how the Sahara's influence ripples through global systems in ways both subtle and profound. Within the desert itself, life has evolved strategies that seem to defy the laws of physics. The Saharan silver ant represents perhaps the most extreme example of heat tolerance in the animal kingdom. These remarkable insects venture out during the hottest parts of the day, when surface temperatures exceed 70 degrees Celsius. Their bodies are covered in specialized hairs that reflect heat, and they move with incredible speed to minimize contact with burning sand. These ants can travel 108 times their body length per second, making them among the fastest animals on Earth relative to their size. They navigate using polarized light patterns invisible to human eyes, creating mental maps of landmarks that guide them back to their underground colonies. Their entire foraging strategy depends on moving so quickly that they can gather food, and return home before the heat kills them. Even more remarkable are the organisms that live in the Sahara's salt deposits. In places where salt concentrations would instantly kill most life forms, specialized bacteria and archaea have found ways to thrive. These extremophils pump salt out of their cells using molecular machinery that operates like biological desalinization plants. They harvest energy from chemical reactions that occur in environments so harsh they resemble conditions on other planets. Scientists studying these organisms are learning about the fundamental limits of life. And the possibilities for discovering living systems in equally extreme environments elsewhere in the universe. The Sahara has become a testing ground for technologies designed to search for life on Mars, where conditions bear striking similarities to the most arid regions of Earth's greatest desert. The desert's geological formations tell stories that span hundreds of millions of years. In the Libyan desert stands the Risha structure, known as the Eye of the Sahara. This massive circular formation stretches 40 kilometers across, creating concentric rings visible from space. Once thought to be an impact crater, scientists now believe it formed when ancient domes of rock were slowly exposed by erosion, revealing layers that record vast spans of geological time. These rock formations contain fossils that reveal the Sahara's incredible past. Whale bones lie buried in sediments that formed when this region lay beneath ancient seas. Dinosaur remains mark periods, when this landscape supported lush forests filled with giant reptiles. Each layer of rock tells a chapter in Earth's long story. Preserved beneath sand that shifts with every wind. The mountains that rise from the desert floor, like islands in a golden sea, hold their own secrets. The Hoggar Mountains in Algeria reach heights of over 3,000 meters. Their granite peaks worn smooth by millions of years of wind and sand. These ancient highlands create their own weather patterns, capturing rare moisture from passing clouds and supporting pockets of vegetation found nowhere else in the Sahara. In the Tibesti Mountains of Chad, active volcanoes remind us that the desert sits atop geological forces that remain very much alive. Kosi, the Sahara's highest peak, at over 3,400 meters, last erupted within recorded human history. Hot springs and geysers scattered throughout the range indicate that magma still flows beneath the surface, heating underground waters that occasionally burst forth in spectacular displays. These volcanic regions support unique ecosystems where life clusters around sources of heat and moisture. Bacteria that thrive in boiling water create colourful mats around hot springs. Plants that have evolved to tolerate high temperatures and mineral-rich soils grow in gardens that seem impossible. In the heart of the world's largest hot desert. The water that feeds these oases often fell as rain when the continents were arranged differently. when the Sahara lay in tropical latitudes under skies heavy with moisture. This fossil water, trapped in underground reservoirs for millions of years, represents a finite resource that connects the present to geological ages almost beyond imagination. Some of these aquifers extend for hundreds of kilometers beneath the sand, forming underground rivers that flow without ever seeing sunlight. The Nubian Sandstone Aquifer, one of the largest groundwater systems on Earth. Stretches beneath multiple countries and holds water that began its journey underground when dinosaurs walked the Earth. Traditional desert peoples developed sophisticated techniques for locating and accessing this hidden water. They learned to read the landscape for subtle signs that indicated underground streams, following chains of vegetation that marked the path of buried rivers. Some communities dug elaborate networks of underground channels called canals, engineering marvels that transported water across vast distances without losing precious moisture to evaporation. The social structures that emerged around these water sources created some of history's most resilient communities. Desert societies developed complex systems for sharing water rights, seasonal migration patterns that allowed grazing lands to recover, and trading relationships that stretched across the entire breadth of the Sahara. These trade networks moved far more than goods. They carried languages, religions, artistic traditions, and technological innovations across cultural boundaries. That might otherwise have remained isolated. The Sahara became a bridge connecting sub-Saharan Africa with Mediterranean civilizations, facilitating exchanges that enriched all the societies involved. The mathematical knowledge that flourished in places like Timbuktu included astronomical observations that required remarkable precision. Desert astronomers mapped the movements of stars and planets with accuracy that would not be surpassed in Europe for centuries. They used this knowledge not only for navigation, but for creating calendars that predicted seasonal changes, crucial for agriculture and trade. The libraries of Timbuktu and other Saharan cities preserved works in dozens of languages and scripts, creating repositories of human knowledge that survived invasions, political upheavals, and climate disasters. Many of these manuscripts remain hidden in private collections, their contents still being discovered by scholars who recognize their importance for understanding medieval African intellectual achievements. The architecture that developed in these desert cities represented brilliant adaptations to extreme climate conditions. Buildings were designed with thick walls that provided insulation against both heat and cold, with wind towers that channeled cooling breezes through interior spaces. And with courtyards that created microclimates where plants could grow. Despite the harsh conditions outside, these construction techniques, refined over centuries of trial and error, created structures that remained comfortable without any artificial cooling systems. Modern architects studying traditional Saharan building methods are learning principles that could reduce energy consumption in contemporary desert construction projects around the world. The textiles produced in Saharan communities reflected both practical needs and sophisticated artistic traditions. Weavers developed techniques for creating fabrics that protected against sand and sun, while remaining light enough to wear in extreme heat. The indigo dyes that gave Tuareg clothing its distinctive blue colour also served practical purposes, providing natural protection against insects and harmful solar radiation. These traditional crafts required intimate knowledge of desert plants and minerals. Understanding passed down through generations of specialists who knew which roots yielded the strongest fibers, which stones produced the most permanent dyes, and which techniques created textiles that would endure the harsh conditions of nomadic life. The musical traditions that emerged from Saharan cultures created sounds that seemed to embody the vast spaces and profound silences of the desert itself. Instruments were designed to project across great distances, allowing communication between widely separated groups during migrations or trading expeditions. Songs preserved historical narratives, genealogies, and practical knowledge essential for survival in challenging environments. These cultural expressions continue to evolve as Saharan communities adapt to changing conditions. Contemporary musicians blend traditional desert melodies with modern instruments, creating new forms that honor ancient traditions while speaking to present realities. The music that emerges from this fusion carries the soul of the desert into a globalized world. The Sahara's influence on human consciousness extends beyond practical considerations of survival and trade. Throughout history, the desert has served as a place of spiritual seeking, where individuals and communities have gone to find clarity, purpose, and connection with forces larger than themselves. The extreme conditions strip away distractions and pretenses, creating space for insights that might not emerge in more comfortable settings. Religious traditions from multiple cultures have found meaning in the Sahara's vast emptiness and profound silences. Hermits and mystics have sought solitude among the dunes, discovering in the desert's apparent barrenness a richness that nourishes the soul. Pilgrims have crossed its expanse not only to reach distant destinations, but to undergo transformations that only such a journey could provide. Modern travellers continue to report similar experiences when they encounter the Sahara's raw power and beauty. The desert challenges assumptions about comfort, convenience, and the necessities of life. It reveals how little humans truly need to survive, and how much we typically take for granted. These realizations can be both humbling and liberating, opening new perspectives on what constitutes a meaningful existence. The night sky above the Sahara offers experiences impossible in most other places on Earth. With virtually no light pollution across vast areas, and with air so dry it creates exceptional clarity, the desert provides windows into the universe that reveal the full glory of our cosmic context. The Milky Way stretches from horizon to horizon, and planets shine with intensity that makes them seem close enough to touch. Ancient peoples used this celestial display for navigation, timekeeping, and spiritual inspiration. Modern astronomers recognize the Sahara as one of Earth's premier locations for astronomical observation, leading to proposals for major telescopes that would take advantage of the exceptional viewing conditions. The study of these celestial patterns has revealed connections between astronomical cycles and the Sahara's dramatic climate transformations. Scientists analysing sediment cores from ancient lake beds have discovered that the desert's green periods coincide precisely with changes in Earth's orbital patterns. Every 21,000 years, our planet's tilt and distance from the Sun shift in ways that intensify summer monsoons across North Africa. These orbital cycles, known as Milankovitch cycles, operate with clockwork precision across geological time. When Earth's orbit brings maximum summer solar radiation to the Northern Hemisphere, the West African monsoon system strengthens dramatically. Moisture-laden winds push hundreds of kilometers farther north than they do today, transforming the Sahara into a landscape of lakes, rivers, and grasslands. The transition from desert to savanna happens with surprising speed. Within just a few centuries, vegetation spreads across areas that had been barren for thousands of years. Rivers begin flowing in channels that had been dry since the previous green period. Animals migrate north from regions where they had waited out the arid phase. Humans follow, establishing settlements and developing agricultural systems adapted to this transformed environment. Archaeological evidence suggests that during these humid periods, the Sahara supported population densities comparable to modern agricultural regions. Stone tools, pottery fragments, and settlement remains indicate sophisticated societies that thrived in landscapes we now find uninhabitable. Rock art from these periods depicts hunting scenes, cattle herding, and fishing activities that would be impossible in today's climate. The end of each green period arrives just as abruptly as its beginning. As Earth's orbital patterns shift, the monsoon rains gradually retreat southward. Lakes begin to shrink. Rivers slow to intermittent flows, and vegetation dies back. The societies that had flourished during the humid phase face choices that will determine their survival. Some migrate south following the retreating rains. Others adapt to increasing aridity, developing the technologies and social structures that allow survival. In desert conditions, these climate transitions have shaped human evolution and cultural development in profound ways. Some researchers argue that the drying of the Sahara around 6,000 years ago triggered migrations that spread agricultural knowledge across Africa and into other continents. The pressure to adapt to changing conditions may have accelerated innovations in water management, animal domestication, and social organization. The underground aquifers that sustain today's oases contain water from these ancient humid periods. Deep wells tap into reserves that accumulated when rain fell regularly across the desert, storing this fossil water in rock formations that act as vast underground reservoirs. Some of this water has been flowing slowly through buried channels for tens of thousands of years, carrying dissolved minerals that tell stories of the rocks through which it has passed. Modern technology has revealed the true extent of these hidden water resources. Satellite measurements detect subtle variations in Earth's gravitational field caused by underground water masses. Ground-penetrating radar maps the extent of buried river channels and lake beds. These tools show that beneath the Sahara's surface lies a complex hydrological system that connects distant regions through networks of underground flow. The The potential for accessing these water resources raises both opportunities and challenges for desert communities. Some countries have begun large-scale pumping projects that bring fossil water to the surface for agriculture and urban development. These projects can transform local economies and support growing populations, but they also deplete resources that formed over geological timescales and cannot be quickly renewed. The question of how to manage these finite water resources reflects broader challenges facing the Sahara. In an era of rapid global change, climate models suggest that rising temperatures will bring increased evaporation and more extreme weather events to many parts of the desert. At the same time, some regions may experience increased rainfall as shifting atmospheric patterns redirect moisture toward areas that have been dry for millennia. These potential changes could trigger ecological transformations comparable to the great climate shifts of the past. Areas that currently support only specialized desert species might become suitable for grassland vegetation. Regions that have been stable for thousands of years could experience dramatic shifts in temperature and precipitation patterns. The impacts on both natural ecosystems and human communities would be profound and largely unpredictable. Understanding these possibilities requires continuing research into the complex interactions between climate, geology, and life in desert environments. Scientists are developing new techniques for reading the environmental history preserved in sand dunes, salt deposits, and underground ice formations. Each discovery adds detail to our understanding of how the Sahara has responded to past climate changes and how it might evolve in the future. The Sahara stands before us not as a wasteland, but as a testament to the extraordinary power of life. To adapt, survive, and flourish in the most challenging conditions our planet can create. From the microscopic extremophiles thriving in salt deposits to the vast underground rivers flowing beneath the sand. This desert reveals that even in apparent emptiness, complexity and beauty persist. The Sahara reminds us that our world still holds mysteries waiting to be discovered. Stories written in stone and sand that span millions of years, and lessons about resilience that could guide us through our own uncertain future. In its endless expanse, we find not desolation, but wonder.